So, we are solving more equations, so just like we did last week, but these equations have a period shrink in them. So if we were to graph like y equals 2 cosine of x, that has an amplitude of 2, and it just does its regular high, middle, low, middle, high cycle in a 2 pi period. But when we put a number in front of x, that causes a horizontal compression, a horizontal shrink. So imagine that spring sort of compressing. And so what I've done here is I've graphed for you in y1. I put the left side in. So there's our cosine function. But what you can see, because of this 3 in there, we aren't just doing one cycle. We have 1, 2, 3 cycles in that 2 pi time frame, if you will. So that 3 means that there are 3 full cycles in the regular 2 pi rotation that we would normally do. So that's it's speeding things up, really. And because of that, if we were to put in y2, where it equals 1, so we have 1, 2, 3, 4, 5, 6 intersections. So today we have to think about all the different ways how many solutions we might have. We have to be very, very careful because our curve is cycling faster, if you will, okay? And so we could get a lot of answers. But Delta Math makes things nice and easy for us. So we just need to make sure to check our answers is really how I like to talk about it. So turn the page, flip over. Oh my goodness, it's like Christmas. Thank you so much. Yeah, perfect. Thank you. You're amazing. Has anyone told you that today?
No, but thank you.
Okay. All right. So solve for values in the interval. We do need to be very careful. Solve for the trigonometric equation for all values of x, well, that's our rotation on our unit circle, between 0 and pi over 3. So what I'd like to do is just think, I know because I have this 6 in front of my function, it's going to make my graph do a bunch more than a normal cycle. So I have to be a little bit careful. Our goal is just like before, we are going to isolate our trig function. So what are we going to do first? Add 2 and then divide by radical 2. Yeah, so secant of 6x equals a positive 2 divided by radical 2. And again, I don't want to rationalize that because secant is a reciprocal function. So I'm going to go ahead and just go ahead and flip both sides. Yeah, so the reciprocal of secant is cosine of 6x equals radical 2 over 2. And so what I'm thinking to myself is, in my unit circle, where is my x value, my x coordinate, equal to radical 2 over 2, positive. So right here at pi over 4, I have the radical 2 over 2 thing. Where else does cosine have a positive radical 2 over 2? 1, 3, 5, 7. Yeah, right here. Radical 2 over 2, again for that x coordinate. So we have, what we're doing now is taking into account this 6x, and that this thing would cycle 6 times in one regular rotation. What I'm going to do is keep counting around, and what I have now is this is 6 times the angle I'm looking for is equal to all of my different places where I get that radical 2 over 2. So I have 1 pi over 4. This was 7 pi over 4. Let's see. So 1, 2, 3, 4, 5, 6, 7. I'm just going to keep counting. I'm going to do a couple extra. 9 pi over 4 if I continue rotating. And I'm going to keep counting. That was 9, 10, 11, 12, 13, 14, 15 pi over 4. You don't have to do too many in delta math, but I'm just continuing to count around my unit circle for all the different times they would intersect. But this is 6 times the number I want, so how do I get rid of the 6? Divide by 6 or multiply by 1/6. I'm going to multiply by 1/6 just because it's a little easier when we have fractions. So those 6's are going to cancel out. So now I have my angle alone, which is really what I was looking for. And I'm going to go ahead and multiply straight across for my fractions here. Pi times 1 is pi over 4 times 6, which is 24. 7 pi over 4 times 6 is 24. 9 pi over 24. And 15 pi over 24. And again, there are so many more answers here. We should have, I don't know, like a dozen. But I only want values for x between 0 and pi over 3. All right. Well, these have a base of 24. What should I do to compare? Yeah, I can multiply this by 8 on top and bottom, so that's 8 pi over 24. So now I can compare a little more easily. Pi over 24, that's within 0 to 8 pi over 24. 7 pi, yeah, that's good. Is 9 pi over 24 good? Yeah, that one's too big. And so these are the only 2 answers I needed because delta math is super nice. And any other trig course I've done, you had to give all of them. So you guys are lucky. Let's just put it at that. But it's a good idea to understand that you might need more answers because we're going many times around that unit circle. This is 6 times around the unit circle because of that 6 in front. Let's look at another. So again, solve the equation for x values between 0 and 16 pi over 5. So what should we do first? Divide by 2, absolutely. So I get sine of 5/8 x equals radical 2 over 2. So once again, I'm thinking about where does my unit circle, where does sine have a value of radical 2 over 2? Pi over 4, yep, that's the, yeah. So there's 1 pi over 4, and right here is also where sine has a positive radical 2 over 2. So 1 pi over 4 and 3 pi over 4. So I'm going to take my inside argument here. So 5/8 x equals 1 pi over 4 and 3 pi over 4. But I'm going to keep counting around just a couple more times just to make sure I'm getting everything I want here. 1, 2, 3, 4, 5, 6, 7, 8. 9 pi over 4 would be the next rotation. 10 and 11. Pi over 4, and I could keep counting if I wanted to, on and on, okay? How do I get x by itself? Yeah, multiply by the reciprocal, 8 over 5, just for ease there, that makes the multiplying much easier. So 8 times pi on top and 4 times 5 on the bottom, so I'm getting 8 pi over 20. Second fraction, 8 times 3 is 24 pi over 20, and then 72 pi over 20, and then 11 times 8 is 88 pi over 20, and there's lots more answers there. But again, I don't necessarily need all of them. We only want to go between 0 and 16 pi over 5. Again, I have a base of 20. This does not. What can I do to compare? Yeah, make the bases match, make the denominators match. I'm going to multiply by 4. That'd be 64 pi over 20. So once again, 72 pi over 20 is too big, and 88 pi over 20 is too big, so we want these first two answers. And we need them reduced. Divide by 4, that'd be 2 pi over 5, and I can divide this by 4 and get 6 pi over 5. Oh, I'm sorry, yep, scoochy, there we go. All right, so same thing we did before, it's just we have this inside argument that we have to isolate first and then go one more step from there. Yeah, not too bad. I think it's just these last two, so that's it. So See, not too much, right? You want to do, well, that's the same. Let's do D. Let's do D. That was horrible. Okay. So between 0 and 2/5. So let's just look at this one. What do you want to do first? Divide by radical 3. So it is important you understand that this 5 pi x, that's everything's inside the cotangent function right there. So I get cotangent of 5 pi x equals 1 over radical 3. And so again, I'm going to the unit circle and asking myself, where does cotangent have a value? Oh, actually, what should I do before I do that? Flip it. Yeah, thank you. Let's flip it. So that would be tangent of 5 pi x. So you don't have to flip it. It's just radical 3. Okay, so since I flipped both sides, now I'm thinking to myself, where does tangent have a ratio of just radical 3? I'm going to draw it a little bigger over here. Pi over 3. Let's see. So at pi over 3, I'm doing short leg, long leg. That's 1/2, and then up radical 3 over 2. So tangent would be sine over cosine. Radical 3 over 2 divided by 1/2. And those 2's crossed out, and yes, I do just get radical 3. So right here at pi over 3 is one answer. And straight across, yeah, which is, let's see, 1 pi over 3, 2 pi over 3, 3 pi over 3, and 4 pi over 3. Good, yeah. So 5 pi x equals 1 pi over 3 or 4 pi over 3. And again, I just want to keep counting. So that was 4, 5, 6, 7 pi's over 3, 8, 9, 10 pi's over 3. And so on and so forth. We could do it a lot of times around, but how do I get x all by itself? 1 over 5 pi. Yep, we're going to multiply by 1 over 5 pi times by 5 pi and divide by 5 pi cancel out, so x is alone. And what happens when I take pi over 3 times 1 over 5 pi? Yeah, the pi on top and pi on bottom would cancel, so we'd have a 1 on top and the 15 on bottom. Good. Again, here pi's cancel, so 4 on top and 15 on bottom. And this again, 7 over 15, because the pi's cancel, and 10 over 15. And so on and so forth. But again, this says 2/5, but we have denominators of 15, so I'm going to multiply top and bottom by 3, so I get 6 over 15. 1/15 is good, 4/15 is good, 7 is too big, and 10/15 is too big. So we just want the first two answers there. Delta math will make you reduce, but other than that, that's all we're doing. More unit circle work there. Okay? Nice. This is good, huh? That was all right. How long was that? 13 minutes.